Right, so in this lesson we're going to talk about solving rational equations. So this is going to be another application of us using the least common multiple of polynomials. So again, if you have not used that skill in a while, you may want to review one of my other videos on finding the least common multiple of polynomials. Okay, first we're going to solve them graphically. Okay, so our strategy is to enter the left-hand side of the equation into y1, the right-hand side of the equation into y2. We're going to plot the two graphs, and we're going to try to use that standard 10 by 10 window first and adjust as needed. We'll find any intersections. We're going to sketch an accurate graph onto our paper and state our solution. Since we're solving an equation, it should be stated as x equals some number. Okay, so let's solve this first equation graphically. 4 over x minus 1 is equal to 2x. Okay, so we're going to start by going into y equals, and we're going to enter this left-hand side of our equation in for y1. So I have 4 divided by x minus 1. And the right side of the equation into y2. So that's 2x. Okay, we're going to try our standard window, so zoom 6, and see if our intersection is there. Okay, and I see that I have two intersections with this graph, so let's find each of them. So second trace, option number 5. I'm going to get close to that first intersection and hit enter 3 times. So I found the first intersection at -1, -2. Let's go ahead and find the second intersection. And we found that at 2, 4. Okay, so now we're going to draw an accurate looking graph onto our papers. It doesn't have to be perfect, but it should represent what we see on the calculator. So here I have y1, and y2. Okay, I had an intersection here at 2, 4, and another intersection over here at -1, -2. So my answer to this equation is x equals -1 and x is equal to +2. Okay, now we're going to solve our rational equation symbolically. So we're going to multiply each of the terms by the least common denominator to clear all the fractions. So similarly to how we would solve linear equations that had fractions, we would find the least common denominator and then clear the fractions. Same idea here. We're going to find the least common denominator and then get rid of all the fractions by multiplying. Okay, we're going to simplify our equation, and we should be given an easier equation, either something linear or something quadratic, that we can solve. And the last step is to check for any extraneous solutions. So again, if you watched some of my previous videos when we were solving proportions, we had to check for extraneous solutions there as well. Proportions are just special types of rational equations. Okay, so let's look at this first example. I have 1 over 3x plus 1 over x equals 4 over 15. So if I look at 3x, x, and 15, I see that my LCD is 15x. So that's what I'm going to multiply this entire equation by. Okay, for this first example, I'm going to write out my distributive property. If it helps you, you should write it out every time. So I have 15x times 1 over 3x plus 15x times 1 over x is equal to 15x over 4 over 15. Okay, so this utilizes our skill of multiplying rational expressions together. So over here, the 3x cancels, and I'm left with 5 times 1, plus here the x's cancel, I'm left with 15, equal sign comes down, the 15's cancel, and I'm left with 4x. Okay, I now have a much simpler equation to solve here. 20 is equal to 4x, so x is equal to 5. Remember, we always want to check for any extraneous solutions, and we always check in the original problem. So 1 over 15 plus 1 over 5 is equal to 4 over 15. 1/15 plus 1/5, which is 3/15, gives me 4/15. That does check. Okay, let's try this next one. So I have 3 over x minus 2 plus 5 over x plus 2 equals 12 over x squared minus 4. So my LCD here is x plus 2, x minus 2. Okay, when I distribute to the whole equation, the x minus 2 cancels. I'm left with 3 times x plus 2. In the second term, the x plus 2 cancels. I'm left with 5 times x minus 2. Equal sign comes down. X squared minus 4 cancels, and I'm left with 12. Okay, again, nice linear equation that we can solve. 3x plus 6 plus 5x minus 10 is equal to 12. 8x minus 4 equals 12. So x is equal to 2. Okay, again, we want to check. Make sure that all these values are in the domain. So I have 3 over 0 plus 5 over 7 equals 12 over 0. So I notice here I have zeros in the denominator. We know if we have a 0 in the denominator, that value is not in the domain. So x equals 2 is not a solution, and there's no solution to this problem. Okay, so in this last example, we're going to multiply our LCD, which is x minus 2 times x minus 4 to every term in this equation. We're left with x times x minus 4 plus 1 times x minus 2 is equal to 2. I notice when I distribute, I'm going to have a quadratic equation. So that means I'm going to want to get it into standard form and solve it by factoring. So I have x squared minus 3x minus 4 is equal to 0. That's going to factor into x minus 4 times x plus 1 equals 0. So my two possible solutions are x is equal to 4 and x is equal to negative 1. Since I have two different solutions, I'm going to have to check them separately. So let's start by checking x is equal to 4. So I have 4 over 2 plus 1 over 0 is equal to 2 over 0. Since I have those zeros in the denominator, that means x equals 4 is extraneous. It's not a solution. Let's check x is equal to negative 1. I have negative 1 over negative 3 plus 1 over negative 5 is equal to 2 over 15. So a third minus 1/5 is equal to 2 over 15. 5 over 15 minus 3 over 15 equals 2 over 15. That also checks. So we have one solution, and that solution is x equals negative 1.